Hello Andre, this is Jack Crane with my Sprint 2 submission. Just going to go over what I have for the new collision stuff and then get into my research progress. So I guess we'll start with the collision test pair command. Changed it, got rid of all the B-sphere stuff in the middle and made it generic to just a PW math methods intersect. This is just the generic one. So inside the PW math methods, we have the generic intersect, which takes the two collidables and returns the correct collision volume for each of the collidables. So once it has these two, it then takes the first collision volume and calls intersect except on it. And then these will be essentially the same in either. This is my implementation of visitor pattern. These functions will be essentially the same in both A, BB, and B-sphere. So in intersect except, it just calls intersect visit on the collision volume sent as a parameter. So in the intersect visit function, I don't need that. In the intersect visit function, it'll just call intersect on the correct collision volume and the other collision volume, depending on which one it is, and then and then depending on the parameters given through the visitor pattern intersect methods, it will hopefully, well, it does output the correct, or go to the correct function and return the proper true or false, depending. Just show how that's done in the user code. So for example, my AI tank, in my initialize, I set the collider model. So I get the model of the tank and the correct volume type. And this is my collidables. So I have this set collider model function, which uses an enum to, depending on the volume type, return the correct collision volume B-sphere. And then in the tank's update method, I'm calling update collision data, which just takes the collision volume pointer and calls compute data on the collision model, which calls compute data on the the correct collision volume, and then passes in the collision model and the world matrix, and then depending on which volume it is, you get the different compute data methods. This one, the one for my AABB, is rather lengthy and just includes a huge if-else-if statement for each of the temps, or for each of the vertices, or axes, sorry. And if I could really use some pointers on how to make this go away, but this was how I got it working, so I'm leaving it in for now. And then in the draw method, I just call show collision volume, which calls the get collision volume and the debug view, depending on the correct collision volume model. So we've got two debug view methods. One calls show B-sphere, the other calls show ABB, and these are located in the visualizer. So in my show B-sphere method, I it's the same as my show B-sphere method is the same as the previous iteration. The only thing I've changed is making my visual commands reusable. So now I have a list of commands, or a pool of commands, and if the list is empty, then I create a new visual command. Otherwise, I basically recycle it. I just set the command to the set the command pointer, the command at the front of the list. Then I set the values through that command, and then pop the command from the front, and then submit it. And in my visual command, when it executes, it calls render on itself, or it calls render to the visualizer, and calls recycle command through the visualizer as well, which just pushes it to the front of the list. So now I should be reusing commands. I'm pretty sure I did that correctly. And then show ABB is essentially the same, but I get the magnitude and the I believe that's this is the math for the translation matrix. I didn't really have a good name for it, but I saw it in the slides, so there it is. And then I have two separate functions for render ABB for the wireframe unit box and the wireframe sphere. And in my I delete the command list, cleaning up the memory. I think that's it. Let me just show you that it works. I don't think I changed anything there. So there's my AAB box rendering. Let's do the collisions, if I can figure out how to turn around. Oh my god, okay. So there's a AABB, OBB, and I just got hit by a bullet, so that works too. If I go AABB to ABB, that collides as well. For my self-test, I can't figure out how to make it so that the test doesn't collide with its own model. For some reason I haven't been able to figure that out, but I do have, and then I have B-sphere collisions as well using visitor pattern. And just in case I didn't go over it, I'll go over the math. So I just have a clamp function and a magnitude function, and then in the OBB, ABB, I get the distance by storing three floats, which are the axes, the clamped center minus the sphere center of each given axes, x, y, and z, and then I take the magnitude of that, and that equals, it's not technically magnitude because I'm not square rooting it, but I do square the radius to get the same effect, and then I don't have to do the costly squaring function, or a square root function. And then clamps just a simple if-else if check. And yes, I believe that's everything. I'm going to move on to my progress in my research. So for the CPU side, there's a couple ideas that I want to run by you. So first, I'm having trouble deciding between, well, so yours is clearly the, after giving me your slides, yours is clearly the best version, probably for me to start with, just because I still, despite all the reading I've been doing, have no idea what I'm doing. So this seems to be the simplest, most effective route for the given engine, obviously, since you've kind of tailored it to our engine. But there were some interesting things that I found that I wanted to run by you. First thing, for the particle, instead of having a particle structure that is an array of particle structures, I would have a structure of arrays. And the reason being was I kind of wanted to do a decent amount of particles, like upwards of 50,000. That would be like the final goal. And I was looking at some of um, these graphs with SIMD implementation of the structure of array implementation, and he was able to get a very significant efficiency return when getting above the 10,000 particle range and using SIMD. So if I can't figure out how to do this, obviously I will revert to your method, and I will probably start with your method to begin with, but I just thought it was interesting that he was able to get such a great optimization going upwards of 10,000 even up to 100,000 range of particles. I'm not sure how portable this will be to our version, but it was just something I thought was interesting. And this version versus your version changes a lot of the internal stuff, so I figured I would just run some of the new stuff by you to see how it went. Yeah, so the particle pattern generator was just his version of burst, basically, and where is his? Is this one? So you can have multiple generators per emitter and basically get different effects in one emitter. This entire article is actually was very useful. But again, his was a lot of optimization stuff that I wasn't sure would be portable to the current version of the engine we have now, especially using drawable and alarmable game object, the drawable and alarmable game object classes. Basically, I think I'm gonna go off of what you gave me, but not sure how portable this new stuff will be. And the renderer version, I'm still not the renderer OpenGL part. I'm still not quite sure how to do. There were a few resources in here that gave me good information about how I should implement the vertex shader, and there's some pseudocode for the render method and how to set up the context. But again, this is the part I'm the most shaky on, and it's kind of holding me back a lot. Yeah. So I think that'll do it for the video. Hopefully I'll have more for you next time for the research, as well as some simple demonstrations. Thank you.